Okay, now this is a Bragg's equation. In 1913, the father and the son, the W.L. Bragg and the W.H. Bragg, worked out the mathematical relation to determine the interatomic distances from X-ray diffraction patterns. This relation is called as the Bragg's equation. Let's see how they are going to explain the Bragg's equation, or how we are going to derive this Bragg's equation. I know there is no derivation, right? They consider the two planes, crystal planes, right? And they are having the crystals lattice, right? And assume that this is a diagrammatic representation to understand the Bragg's law, and the X-ray is incidenting on this crystal point. This is known as the incident X-rays, and this is known as the incident X-rays, right? When incident on the plane, again it will be reflected. This is known as the reflected X-rays. This is known as the reflected X-rays. There are two planes, right? There are two planes, and they are reflected, and the incident on the angle, this is called as the glancing angle theta, and it is also reflected as at the angle theta. Like the same way, the another incident X-rays will incident on this crystal lattice on the second plane, right? And it is reflected. Again it is reflected. I will take it as the point A. I will take it as the point A, and I will take it as the point B. A rays and the B rays. Again it will be reflected again at the angle theta. And the distance between the two planes, internuclear distance, is represented as small d, and I will take it as O, and I will connect these two crystal lattices, right? These are the two parallel planes of crystal structure, right? Therefore, this is the diagrammatic representations of the to understand the Bragg's law. This is the crystal planes, and this is a crystal lattice, right? When a incident X-rays is incident on here, again after incident they will be reflected at same angle, incident X-ray at same angle theta, and it is also reflected at the same angle theta. Again for another plane it will be the incident on the X-rays same, and it is reflected, again it is taken as theta. The internuclear distances between the two planes, it is represented as the small d, right? Therefore, when a beam of incident, see, as I said, when a beam of incident X-rays falls on a crystal lattice at an angle theta, and these rays reflected at the same angle theta, right? Therefore, if we take the exponential line, means this is the exponential line, therefore we can join this one. This is the exponential line. So at the same way, if we take, I will take this is a C, and I will take this is as D, reflected rays, or I will take the C. Therefore, from C, if you draw a exponential, again it will be joined here. Therefore, I will name this as X, and I will name this as Z, right? Therefore, if we take exponential from line from A, means extending, you are going to extend that one. Therefore, you will meet here, that is at Z. And like the same way, from the reflected C, it will be extended as exponential, and it is represented as X, right? Therefore, if you observe the triangle XO, and I will take it as Y, and I will take this point as Y. Therefore, triangle XOY, right? That is also theta. Then if we observe the another triangle, then ZOY, that is also having the theta, right, at the glancing angle. Therefore, if the distance between the AO is nothing but it's equal to the distance between the AX. Therefore, we can write it as the distance between AO is nothing but it is equal to the bx. Like the same way, the distance between the CO, the distance between the CO is exactly equal to dz, is exactly equal to the dz. This is the distances, right? This is the triangle angle and this is the distances, right? Therefore, if you take the path difference, is nothing but xy plus yz. Xy, where is that xy? Xy plus yz. This is the path difference. If you take xy plus yz, I will call it as the equation 1. Therefore, path difference is defined as, it is nothing but the path difference is defined as the integral path of the internuclear distance or integral path of the wavelength. Therefore, path difference is defined as integral part. It is nothing but the integral part of wavelength. Integral part of the wavelength, that is n lambda. I will take this equation 2, right? Therefore, by comparing that one, you know that one. Therefore, path difference ನಮಗೆ ಏನಂತ ಗೊತ್ತಿದೆ n lambda. Therefore, n lambda equals xy plus yz. This is the equation 3. Right? Therefore, we know that sin theta. The sin theta is nothing but the sin theta can be defined as the length of the perpendicular divided by hypotenuse, right? This is the right. Therefore, if you observe the triangle XOY, therefore sin theta, what will happen? xy means, which is length of the perpendicular xy divided by oy, means hypotenuse oy. This is the hypotenuse and this is the length of the perpendicular at triangle xy. If you rearrange this one, what will happen? xy equals sin theta into oy, right? Therefore, what is that oy? Oy is nothing but the internuclear distance d. Therefore, you can write it as d sin theta. Take it as equation 4. Therefore, observe the triangle. Again, if you observe the triangle ZOY, if you triangle ZOY, what you can write? Sin theta equals ZY divided by OY. ZY divided by OY means length of the perpendicular divided by hypotenuse. Again, if you rearrange this one, what will happen? ZY equals OY into sin theta. OY is equal to sin theta. Or we can write it as, that OY is nothing but the D. Therefore, ZY equals D sin theta. You take it as equation 5. Therefore, that one, the internuclear distances, the path difference, equation 3 is nothing but n lambda equals xy is what? D sin theta. Xy is D sin theta. Then plus yz is, zy or yz is D sin theta. Therefore, finally, the Bragg's equation is nothing but 2D sin theta. The Bragg's equation is 2D. N lambda is equal to 2D sin theta, right? Where n is the order of reflection or order of diffraction. Order of diffraction means, for example, here there is a 2 planes. Therefore, if there is a 2 layers or the 2 crystal planes present, then order of the diffraction or order of the diffraction is 2. Order of the diffraction is 2, like this. If there is a 3 planes, then order of diffraction is 3. Therefore, n is the order of diffraction and lambda is the wavelength of the X-rays and d is the internuclear distances between the 2 planes and theta is the glancing angle. And I think you know that one. What is that? The sin theta. If it is sin 0 means the value will be 0. If the sin is 30 degree, then it is value is off. And you know that sin 45 degree value is 1 by root 2. Then same 60 degree 3 by root 2. And sin 90 degree is 1. right? If you want to know these values, because there is a problem. Therefore, finally, the n lambda is equal to 2d sin theta, means the Bragg's equation. This is the Bragg equation. Means the X-ray diffracted atoms in crystal planes obeys the laws of reflection. Obeys the laws of reflection. Means the two rays reflected by successive planes will be in the phase if the extra distance traveled by the second ray is nothing but is an integral number of the wavelength. They showed that the Bragg's, means both father and son show that first one, what is that? The X-ray diffracted from the atoms in the crystal planes obeys the laws of reflection, and second one, what they show means the two rays reflected by successive planes will be in phase if the extra distance traveled by the second ray is nothing but the integral number of wavelength, that is called as the n lambda. That is called as the n lambda. This is all about the Bragg's equation. This is called as the Bragg's equation, right? And it is very important, and there is no derivation. If they ask, means you just write it, the laws, and you can write the diagrammatical representation, and directly you can write this equation, and you want to explain the terms, right? Therefore, n lambda is equal to 2d sin theta. This is known as the Bragg's equation, right? Therefore, the n is equal to 1 means there is this is nothing but the first order reflection, where n is equal to 2 means it is a second order reflection, right? Therefore, the Bragg's equation is used chiefly for the determination of spacing between the crystal planes. This is the spacing between the crystal planes, that is d. For X-rays of a specific wavelength, the angle theta can be measured by the help of Bragg X-ray spectrophotometer, right? Therefore, the interplanar distance can be calculated with the help of Bragg's equation. Therefore, Bragg's law is mainly which is used to determine the internuclear distances between the two successive plane of the crystals. I hope it is understood. Thank you.